A box of 5 kilograms is pulled from rest along a rough horizontal surface. So if it's on a rough horizontal surface, we can assume that we are going to have a frictional force. If I were to put all the forces onto this diagram, which wasn't what was asked of the question, but long questions might ask this, we would need 5 times 9,8 over here, which would be 4, something, and that would be your weight. You would have a normal force, which would be exactly the same in magnitude. Then you would have an applied force, and that would be 4,5 newtons, and there would be, working against that, a frictional force. That's ultimately what we are going to have to find the value of. Okay, the box moves 6 meters in 4 seconds. I need to work out frictional force. Well, I do know that force resultant is equal to mass times acceleration, which is equal to the big force, which is going to be the applied force, minus the small force, which will be the frictional force. I know the mass, it's 5 kilograms. I don't know the acceleration. I know 4,5, and I don't know frictional. And frictional is what I'm looking for. So maybe if I find this acceleration value, I will be able to solve the problem. So I also know that this object moves 6 meters in 4 seconds from rest. So I can say distance is equal to, or displacement is equal to ut plus a half at squared. I know nothing about the final velocity, so I choose an equation of motion that does not include the final velocity. I then substitute in my values, and don't forget the half and don't forget the squaring. And when you rearrange that, you find that you get 0,75 meters per second squared. That is the acceleration of this system, so I can put it in over there. Once I then solve over here, I find that my frictional force turns out to be equal to 4,5 minus 3,75, and I land up with 0,75 newtons. This number over here, by the way, is absolutely meaningless. A student pulls 2 masses which are tied together as shown with a horizontal force of 12 newtons. The mass of the string connecting the 2 pieces is negligible. Calculate the acceleration of the mass pieces and the force exerted by the connecting string on each mass piece. Remember, that's going to have a tension. That is an equal but opposite action-reaction pair. So again, I'm going to just highlight how we would draw this because you may be asked to do this. Remember, it must be with a ruler, and now we're going to put our 12 newtons over there, and we were told that there was no frictional force, which is great news, but there is a tension acting backwards. You would write the whole word tension over there. On the 1 kilogram block, there's tension acting forwards, and there is no frictional force whatsoever. So, force resultant is equal to big force, tension, minus small force, there is no small force. There's nothing acting backwards at all. Force resultant is equal to big force minus small force. This whole system is moving towards the right, and therefore we know that the 12 Newton force is bigger than the tension. 1 times acceleration is tension, and over here 3 times acceleration is 12 minus tension. But tension is tension, so I'm going to cross that tension out and I'm going to put 1a in, and I then land up where I have to throw that over, so it becomes 4a is equal to 12 and a is equal to 3 meters per second squared. I have solved for the acceleration. Determine the magnitude of the force exerted by the connecting string. That force is called the tension. I can substitute this 3 into either of the equations. 1 times 3 is going to give me 3 newtons. And if I did it into this equation over here, so substituting the force resultant, so it's 3 times 3 is equal to 12 minus the tension. It would be 9 equals 12 minus tension, and tension would turn out to be 3 newtons. So it doesn't matter which way you do it, you're going to land up with the same answer. Two blocks, 5 kilograms and 3 kilograms, are placed next to each other on the surface of a table. Again, I separate out the blocks. 3 kilograms. 3 kilograms has got 26 newtons that way, and it is being resisted by the 5 kilogram block. We can call that part of an action-reaction pair. There's always a force over here where the two surfaces are together. Action, reaction of the 3 on the 5 and the 5 on the 3. So we've got that, and we are told that there's a 3 Newton frictional force. The other block, 5 kilograms, is equal. We've got, obviously, something's driving it forward because this whole system is moving to the right again. So it's going to be this action-reaction pair that pushes it forward, and it experiences some friction as well. So force resultant is equal to big forces minus small forces. Force resultant is 3 times the acceleration of the system. In this case, the whole system is moving to the right, so 26 is the biggest. The action-reaction pair is working against it, and 3 is working against it. That's the friction. Force resultant in the 5 kilogram block's case is 5A is equal to the system's moving to the right, so the action-reaction pair is big, and the 5 Newton is small. Now let's rearrange these so that they're both in terms of the action-reaction pair, and you get the action-reaction pair is equal to 23 minus 3A. Here, AR is equal to 5A plus 5. Do the simultaneous equation, and you land up with A being equal to 2,25 meters per second squared towards the right. Once I substitute that back, I now need to determine the force. So this is my action-reaction pair. The 3 kilogram exerts on the 5 kilogram. It's going to be to the right. Doesn't matter which equation I substitute this number back into. I can substitute it into either one, and I'm going to choose this one. AR is 23 minus 3, 2,25, and I land up with that being 16,25 newtons right. A body of mass 3 kilograms hangs on one end of a frictionless pulley. On the other end, there's 50 newtons. So I know that this tension is 50 newtons, and the tension's the same all the way in that string, so there's 50 newtons acting up over here. This force over there is 3 times 9,8, which is equal to 29,4 newtons down. So force resultant is equal to big force, 50, minus small force, 29,4. 3 times A is therefore going to be equal to 20,6, and A turns out to be 6,89 meters per second squared upwards. It says calculate first the resultant force on the 3 kilogram block. The force resultant is going to be equal to those two subtracted from each other, so it's 20,6, and the acceleration we've just worked out.